4.128 and 133, the left one and the right figure right here. The couple M is applied to a beam of the cross-section shown in a plane forming an angle beta with the vertical. We got our beta right here. Determine the stress at point A, point B, and point D. All right, so the first thing we want to do is we want to make sure we have the angle with respect to the z-axis. So this is going to be 60 degrees, and then we'll deal with the other figure later. So we'll start with 4.128. Now, I want to say this is a moment that is not along the principal centroidal axis, so we'll have to decompose it. We'll have to decompose it in these two moments. So we know, what do we know? Well, we know that this is 60 degrees, this is 30 degrees, this is, so if we extend these, this would be 60, 30, well, that doesn't help us. However, we can notice that this is perpendicular right here. So we can say that this is also 30 degrees. This is 30 degrees. So we can say, and look, the z is positive on the left, so keep that in mind. When we decompose this, it's going to be m cosine of 30 degrees, which is going to be what? 200 times the square root of 3, which is 346. So we'll say 346 pounds inches, but it's going to be negative. It's going to be negative because the z is positive in this direction. We're going to do the same with the other one. It's going to be the sine of 30 degrees, m sine of 30 degrees, which is a half, so we get 200 pounds times inches. All right, so we decomposed the vectors. That's actually step 2. The first step is find the principal centroidal axes, principal centroidal axes, and the moments of inertia about those axes. And so the moments of inertia are I, Y, and I, Z for this case. And it's a rectangle, and we're assuming uniform distribution, density distribution. So we can say that IY is going to be 1 over 12 times the side that is parallel to Y. So that's going to be 0.6 plus 0.6, which is 1.2 inches, and the side that is perpendicular, which is 0.4 inches cubed. We do the same with the Z. The sides that are parallel and perpendicular are going to be swapped, and let's just make sure. So 0.4 is the side that is parallel to Z, and 1.2 is the side that is perpendicular. So now we can put that into the calculator and feel good about ourselves already that we did something towards solving this problem. And so 6.4 for the top one, 6.4 times 10 to the negative 3 inches to the fourth. The bottom one is going to be 1 over 12 times 0.4 times 1.2 to the third, which is going to be 5.76 times 10 to the negative 2 inches to the fourth. All right, so now that we have that, step 2, decompose the moment about the centroidal axes. Y, and Z. So we've done this. We got m cosine, negative m cosine of 30 degrees, which is 346 pounds inches, negative 346 pound inches, because remember we're in the negative direction of the Z, according to the Z that they gave us. And then for m sine of 30 degrees, that's going to be 200 pounds times inches. And these are going to be what? Well, let's see. This component is parallel to the Z direction, so that's the MZ. mz, and this is going to be my because the vector of the moment points parallel to the y direction. But remember that this vector tells you where your thumb of the right hand points. The fingers should be curled like this. So the moment here is like this, and here the moment is like this. All right, let me get rid of these. And that, oops, good. So now what are we gonna do? Now step 3 is find the direction for the points requested. So we have point A, B, and D. For point A, so Y, A, and ZA. YA is the distance along the y-axis from the z-axis, and that is 0.6 inches. This is where you can make mistakes with the signs. And ZA is the distance along the z-axis from the y-axis, and that is, for A, it's in the positive z-axis, that is 0.2, half of that side. We do the same for the YB and the ZB. Be careful with the signs. This is where I make most of my mistakes. So here we're going for, along the y-axis, we're still going in the positive y-axis. So that's still going to be 0.6 inches. But ZB is going to be the distance along Z from the y-axis. But look, to go to B, we're going in the negative direction, so we need a negative sign, a negative 0.2 inches. And finally, we have the last one, point C, which is going to be what? Well, it's going to be, did they ask us? No, sorry, point D. Point D, my bad. Point D. What is D? Well, we're going down along the y-axis by 0.6, so that's going to be minus 0.6 inches. And we're going to the right along the z-axis, so that's also negative because our z-axis is positive on the left, according to this graph. All right, that they gave us, so we didn't decide this. All right, so now that we have this, what we're going to do is we're going to calculate the stress in the x direction with superposition. And I like to reason through if something makes sense or not. So if I have a moment and it's a negative moment about the z-axis, right? If it's a negative moment about the z-axis, I'm going to have tension at the top, right? I'm going to have tension. This is the part that's the conceptual part. Because if I am bending around the z-axis in the negative direction, sorry, I need to say, if I bend in the positive direction, then I'm going to have compression at the top here. So I'm going to have a negative in front of that part. So sigma x is going to be minus mz y over iz. On the other hand, if I bend along the y-axis, the positive y-axis, what's going to happen to my x-axis? I'm going to have a tension on this side. So on the positive side of z, I already have tension, which is positive, so I don't need to put a negative sign. So that's kind of how I reason it. It took me a while to understand that, but I feel like if I take the time, that's the best way for me to understand what I'm doing. So for A, so sigma at A is going to be minus MZ, which we said is negative 346 pounds inches. 346 pounds times inches times our y at A, which we said is 0.6 inches. All of that divided by IZ, which we said is 5.76 times 10 to the negative 2. So here we put 5.76 times 10 to the negative 2, and that's going to be inches to the 4th. And then I'm going to add my MY, which is 200 pounds times inches. And we have our Z, our ZA, which is 0.2 inches. All of that over IY, and IY is 6.4 times 10 to the negative 3. 6.4 times 10 to the negative 3 pounds, not inches to the 4th. All right. So I'm going to copy this because the formula is going to be similar for B and D. So I'm going to copy this. I'm going to paste that over here. Make sure I have it aligned. And then I'm going to paste that one more time here. And I'm going to say, hey, this is my B, this is my C, this is my B, this is my C. So what I'm going to do now is I'm going to have to change these distances. So let me make that happen. And so what are we going to have? Well, we're going to have 6 for point B, 6 inches and negative 2 inches. So for point B, 6 inches and negative 0.2 inches. And I think I meant 0.6 inches. So 0.6 inches. And at the top, I did not mean to erase these. And 0.2 inches. And then the last one is negative 0.6 and negative 0.2 inches. All right, so we have 1, we have 2, we have 3. Now we're going to input everything into the calculator. This is going to be our drum roll for this exercise. So what I'm going to do is I'm going to write the minus of minus 346 times 0.6 divided by 5.76 times 10 to the negative 2, all of that added to another fraction, 200 times 0.2 divided by 6.4 times 10 to the negative 3. All right, so we're pressing send. And we get 9.85 KSI. And so this is in tension, assuming all of our signs worked out as they should have. And then we're going to do the same thing, but now we're going to have what? We're going to have a negative 0.2. That's going to give us minus 2.65 KSI. So this is in compression. And then the last one is going to be here. And now we're going to have the 0.6 that's also negative. And so that gives us a negative 9.86 KSI, which is compression. And that's our results. And they're confirmed as well. So this is how to do combined bending or asymmetric or unsymmetric bending. I hope this was useful, and I'll see you next time.